Good morning, Seattle!
Woo!
And welcome to St. Ignatius News. Today we have some very intriguing news about the 3 laws. Live to Miss Lee Jensen on the scene with this breaking news.
Good morning, Monica. Today we are here with chemist Antoine Ravizur and his wife Anne-Marie. Putting aside candlelit dinners, this couple spends their days carrying out chemical reactions together. How romantic. Antoine, could you tell us a bit about your most recent discovery?
It's Lavoisier. And of course, I've just discovered the law of conservation of mass, which states that mass is neither created nor destroyed through chemical or physical means, that is.
Wow, impressive. Could you tell us a little more about how you discovered this law?
Sure thing. It started out as a little mission of mine to discover the true nature of combustion, that is, disprove the theory of phlogiston.
Which is?
I got it, honey, I got it. Phlogiston was composed by George Stahl in the early 18th century as a universal component in everything that catches fire. But I wasn't convinced. I conducted experiments burning phosphorus and sulfur and found that they gained weight by combining with air. If phlogiston had been present, the elements should have lost weight as it was burned off. Anyways, I eventually came to find that oxygen is involved in combustion, and through all of my experiments, also found that mass is neither created nor destroyed.
None of which, by the way, could have been done without the proper equipment and translations of English works for Antoine, which I did.
Well, I guess.
Everything's laid out in our book, actually.
My book.
Our book, the elementary treatise on chemistry. Our use of proper and accurate scientific instruments was crucial to finding the law of conservation of mass. And I have outlined many detailed drawings of the experiments we conducted and the precise instruments we used.
This is all very impressive. Could you two show us exactly how this law works?
Certainly. Let's head over to the scholarly panel.
The chemical formula for carbon dioxide is CO2. If you write an equation for the law, it states that the masses of the reactants equals the masses of the products. If you plug carbon dioxide into this equation, then the mass of carbon plus mass of oxygen equals the mass of carbon dioxide. Therefore, if 12 grams of carbon react with 32 grams of oxygen, then it will yield 44 grams of CO2, because 12 plus 32 equals 44.
All right then. Amazing work, you two. Anne-Marie, could we see one of your drawings of an instrument used to help determine this law?
Sure, our book's right here actually, and here's one I did of a device we use to collect gas and measure its volume.
Wow, beautiful work. Thank you both so much for your time.
Alright, fascinating stuff. Now back to Lee with the discovery of our second law.
Thanks, Monica. I'm here with Mr. Joseph Proust. Joseph Louis Proust, a French chemist working in Spain, was born September 26, 1754. He studied chemistry in his father's apothecary shop and taught chemistry with Pilatre de Rosière, a famous aeronaut. Mr. Proust, I've been told that you are credited for discovering the law of definite proportions. What is this law?
Well, it's very simple. A given compound always contains exactly the same proportion of elements by mass, regardless of amount.
Amazing, but I'm still a little confused. Can you show us how it works?
Indeed. Let's take a trip over to the scholarly panel. Here we have 2 different compounds of CO2. One is made with 12.01 grams carbon and 32.00 grams oxygen. The other is 1.00 grams carbon and 2.664 grams oxygen. Now we can calculate the mass percent of each element in the compound. Mass percent of the element equals mass of element in compound over the mass of the compound times 100%. Now let's look at that first compound. We know the mass of each element, but first we need to find the mass of the entire compound. So, mass CO2 equals 1 times the mass of carbon plus 2 times the mass of oxygen. Now that we have the mass of CO2, we can find mass percent. Let's start with carbon, using that first compound on top. Mass percent carbon equals 12.01 grams carbon over 44.01 grams CO2 times 100%. That equals 27.29% carbon. Now let's find the percent of oxygen in the compound. Mass percent oxygen equals 32.00 grams oxygen over 44.01 grams CO2 times 100%. That equals 72.71% oxygen. Now let's check our work. 27.29% plus 72.71% equals 100.00%. The mass percent we calculated for carbon and oxygen will be the same for every compound of CO2. Remember that second compound we have written on top? It contains the same ratio of percent carbon to percent oxygen.
Wow, chemistry is amazing. Back to you, Monica.
Thanks so much, Lee. Now on to our last law, featuring an exclusive interview with John Dalton himself.
I'm here with Harry Potter. I mean John Dalton. He has just discovered yet another law, the law of multiple proportions. John was born in 1766 in England and was a teacher when he was just 12 years old, before he became a renowned chemist and father of modern atomic theory. How are you, John?
I'm doing well, thank you.
Anywho, how did you come by your discovery?
Well, I published it in the first volume of my New System of Chemical Philosophy book from 1808. I experimented with various elements including hydrogen, oxygen, carbon, and nitrogen. For example, I knew that carbon could form two oxides by reacting with oxides in different proportions. When I measured the masses of the elements whose proportions I changed, I discovered that the masses of them could always be simplified into small whole number ratios. That is the law of multiple proportions. When two elements form more than one compound, the masses of one element that combine with the fixed mass of the other are in the ratio of small whole numbers.
Wow, that is way more confusing than the last two laws. Chemistry students are going to love that law. To get a better explanation, let's go to the scholarly panel.
Here we have one compound of acetylene, C2H2, and one compound of ethylene, C2H4. Acetylene has a ratio of 12 grams carbon to 1 gram of hydrogen, and ethylene has a ratio of 6 grams carbon to 1 gram hydrogen. The law of multiple proportions states that the ratio of acetylene over the ratio of ethylene will equal a small whole number. In our equation, 12 divided by 6 equals 2, a small whole number.
Thank you so much for joining us today on this special. We'll see you after the break, and remember to go learn more at https://www.saintiggynews.com/the_3_laws_of_chemistry. This program is sponsored by viewers like you. Over and out.